So if you were with us last class, you will recognize some of this stuff. We're moving forward with solving linear equations. Last time, we looked at a couple of ways of solving linear equations with the table and graph. As a reminder, a solution to an equation is a value for x that will make the equation true. The value of the left and right side of the equal sign should be the same. That means it's true. Okay? We get the same values on both sides of the equal sign. All right. So that's kind of our guidelines here for solving. In our previous class, we saw how to find solutions using the table and graph representing a linear function. This is a slide from our previous class where we look at the function or the equation x minus 2 equals 5. And we can see the solution on the table right here where x equals 7. We get that x minus 2 equals 5. Okay, so that's our solution, x equals 7. And using the graph, if we find the value of y that I want on the y-axis, right, and I trace that over to the line, and then I trace that line down to the x-axis, I get the solution. And again, in this case, x equals 7. Right, so this gives me ways of using the table and graph to find the solution. Now, this is a very simple example with x minus 2 equals 5. Using a graph and using a table can be very helpful in more complicated equations, which right now we're just dealing with equations with lines, but I can tell you from personal experience in higher level math classes that when you start dealing with equations that aren't normal, that create like curves and like wavy lines and things like that, looking at a graph to get an idea of what the solution is incredibly helpful. So that's why we're looking at it in a very basic sense right now, because it becomes a much more valuable tool later. Are there any questions about what we did last class? So today we're going to get into solving algebraically, which some of you may have seen before. All right, so as we said, today we're going to look at how to solve a linear equation algebraically. Right? Algebraically just means with math, right? Using algebra. Right? We have some basic steps to use when solving linear equations. This gives us a kind of a roadmap on how to do these things. Our first step, simplify each side of the equation by removing parentheses and combining like terms. Okay. So we want to simplify everything as much as possible. If there's a bunch of parentheses going on, I want to do what's going on in those parentheses if possible, so I can get rid of the parentheses. Anything that has the same variable attached to it, I can combine into a single term. Any just plain numbers, I can combine into a single term. So that's what this step means. I want to make everything as simplified as possible. Step 2, we're going to use addition or subtraction to isolate the variable term on one side of the equation. This means I need to add or subtract the regular numbers that are next to my term that has the variable, right? So that I have on one side of the equal sign just that term that has the variable attached to it, right? The variable and the coefficient. And on the other side, I have just numbers. Right? So I want to make it so that that's what we mean by isolate the variable term. Step 3, we're going to use a multiplication or division to solve for the variable. Right? If there is a coefficient still left with our variable, like a number attached to x, we need to get rid of that number by multiplying or dividing by some number, so that all I'm left with is 1x on one side of the equal sign and a number on the other side. We have this note. It's a little helper thing here. Fractions may be removed by multiplying each side of the equation by the common denominator. Right? So if I'm dealing with a fraction, which fractions can be difficult to work with, I can get rid of the fraction by multiplying by the common denominator. Okay. And that means multiplying by, so if there's fractions on both sides of the equal sign, I want to multiply by a number that will eliminate both of those fractions, so to say. We can think of it as like, so if I have 1/3 equals x over 5. Right? I don't like dealing with fractions. I can eliminate the fractions, right? A common denominator for both of these, like the smallest number that 3 and 5 are both a factor of, okay, that's the common denominator, would be 15. So I can rewrite this by multiplying each side by whatever number, right? 15 in this case is the common denominator. So if I multiply by 15 on both sides, right, I'll end up with 15 over 3 equals 15x over 5, which when we simplify, 15 divided by 3 is 5, and 15 divided by 5 is 3. Right? And so I get whole numbers, which are much easier to maneuver and work with within equations. So that's what this note means. I can get rid of fractions if I want to. So these are guidelines. These are steps for solving linear equations. All right. So before I go on to the examples, does anyone have any questions, or can you, if you're writing these steps down and you need another moment before I move on? Cool. Okay. I will wait. Eileen, so the 1 over 3, I just picked some numbers so I could show you how to multiply by the common denominator. So this initial 1/3 equals x over 5, I just picked stuff. Yeah, it's okay. It looks like we're ready. All right, so we're going to do some examples. Right, hopefully this will be helpful in you guys seeing how to do this kind of stuff. So yeah, we're going to get doing some examples here. We're going to start with one-step equations, and we'll go to two-step equations, and we'll go to multi-step equations. We'll do some different types of each. All right, and again, notice that they're not like we have V, we have P, we have B, we have N. You don't have to use X. There's no rule saying X must always be your variable. You can use any letter you want. The only letter I say not to use, well, there's two letters I typically would not use. Those would be E and I And that's because those are actually numbers in mathematics, similar to like pi is a number. So are e and I. So you don't want to use those as variables because they have special meaning within mathematics. Any other letter though, totally fine. All right, so let's look at question 1 here. We have 26 equals 8 plus v. I need to get v by itself. I have no parentheses. I have no like terms to combine on either side of the equal sign. So now I look at using addition or subtraction to isolate the variable. I need to use subtraction. I can subtract 8 from the right-hand side, which means I must also subtract 8. Yes. Yes, Eileen. Excellent. All right, I have to subtract 8 from each side. If I do something to one side of the equal sign, I must always do it to the other side to keep the equation balanced. Okay? So the 8 minus 8, my 8's go away. I'm left with only v on this side. 26 minus 8 is 18. We get 18 equals v. Then we got to check it. This is just a habit to have. I know this is a simple example, which we're only adding or subtracting. However, we want to be in the habit of checking our work. So we check. We say, okay, v equals 18. Let's put it back in the equation. 8 plus 18, which is v, equals 26. It was supposed to equal 26. Hooray. Everything works. So now we're done with question 1. Question 2, we have 3 plus p equals 8. All right. So again, there are no parentheses. We have no like terms. We're going straight to, do we add or subtract something to get p by itself? In this case, we should subtract 3 and subtract 3 from the other side. Right. These 3's are gone. Left with p. 8 minus 3 equals 5. Right. And again, some of these we could kind of look at and be like, oh, should be this number, right? Because it's only one step. There's only one operation going on. But again, we're just practicing. We're trying to build the habit of using the process of solving equations. So I'm kind of doing more work than normal, but that's okay. And again, we'll check our work. We have 3 plus 5 equals 8. We needed it to equal 8. Hooray, everything worked. All right. Same thing going on here. We have 15 plus b equals 23. We're going to subtract 15 from each side. 15 is gone. We're left with b. 23 minus 15 equals 8. Okay. And again, we'll check our work. We have 15 plus 8. And we get 23. We've done an excellent job. All right. And we'll do the last one here. Negative 15 plus n equals negative 9. Yep, we need to add the 15 because we're doing a subtraction of 15 here, which means we add 15 to this side. Our 15s go away. We're left with just n, and n equals negative 9 plus 15. All right. Which we can also think of as 15 minus 9 if we want to. Make it easier. Right. Which will lead us to 6. If I can math there. Right. And again, we'll check our work. We have negative 15 plus 6 equals negative 9. Excellent. So again, we've only had to use step 2 within our steps for our one-step equations. And these are ones, they literally involve one thing to do to get to your solution. You have addition or subtraction in this case. Anyone have any questions about these examples? No. Right. Does anyone need another moment to write down any of these examples? Let's look at our two-step equations. All right. Question number 1 here, we have 6 equals a divided by 4 plus 2. In our steps, we have to do the addition or subtraction before we can do multiplication or division. And that's just to keep everything a little cleaner. There's less steps that way. So my first step here, we'll have -2 from each side. Plus 2 minus 2 is 0. 6 minus 2 is 4. That will equal a divided by 4. I then need to multiply by 4 on each side of the parentheses. Multiplying by 4 is the opposite of dividing by 4. That's why I'm choosing to multiply. I need to get rid of that division, right? So that cancels out the division by 4, leaves me with a. 4 times 4 is 16. We get a equals 16. Check our work. We have 16 divided by 4 plus 2. 16 divided by 4 is 4 plus 2 equals 6. Hooray, everything worked. Okay. Again, I'm showing the extra part of checking your work because it is important. This is how you find out if you made an error, right? You may have done all of your processes correctly, but you wrote down 15 instead of 16 for some reason, right? Which then obviously makes it wrong, but if you don't check it, you may not realize it. It's very easy to make arithmetic errors. Excuse me. Right? That's honestly one of the most common mistakes within like any level of mathematics is just making what's called an arithmetic error, which means you like added one. Oh, thank you. Yes, I did sneeze. Thank you. It's like adding one when you meant to subtract one. It's not that you don't know what you're doing. It's not that you don't know the process. It's just that you made an error. Right? And those are the most common errors throughout like college mathematics as well. It's just making simple mistakes. So you have to check your work to make sure you didn't do that. Right? So this is the question number 2. Our first step will be to add 6 to each side. Our minus 6 is gone. We have x divided by 4 that comes down with us here. Negative 5 plus 6 is 1. Again, we're going to have to multiply by 4 on each side. The division goes away. We're left with x equals 4. Once again, we will check our work. We have negative 6 plus 4 divided by 4. Negative 6 plus 1 equals negative 5. And that's what we wanted. Okay, any questions so far? Okay. All right. Look at number 3. 9x. You don't understand the way I have to check? Okay. So I'll answer both questions for Eileen and for Nick. So Eileen, your question popped up first on the chat, so we'll do that one first. The way that I'm checking, all right, is I'm replacing, so like in question number 2 here, I got the solution was x equals 4. So that means if I replace x with 4 in the original equation, which was -6 plus x divided by 4 equals -5, that if I did all my work properly, I should get -5 as the result, right? So I just replace it. I rewrite the equation, -6 plus 4 over 4, because x is now 4, right? Because this x here, right? And it gets replaced with 4 over here in my checking of the work, okay? And then I just do the math and make sure, right? I'm checking to make sure that when I do the math, I get the -5 that it was supposed to be equal to as my result. So that's what the check is doing. And then Nicholas' question, he's asking me to break down what I did. So you're welcome. For question number 2 here, right? I'm starting with the equation -6 plus x divided by 4. This is the function, so to say, and I want to know what value of x will make this thing equal to -5. So that's what I'm trying to solve. And so then I'm following our steps from up here, right? I want to simplify, I want to use addition or subtraction, and then use multiplication or division to solve. In this case, there's nothing to simplify. I don't have any parentheses that I can do the operations that are inside those parentheses, and I don't have any like terms on each side of the equal sign. So I get to jump right to addition or subtraction. And I need to add or subtract so that I get left with the term that has the variable attached. So that's my goal. I want, on one side of the equal sign, I need this to be by itself. And I need all the numbers on the other side. So since I need the x over 4 by itself, my first step is going to be to add 6 to the left-hand side, because -6 plus 6 is 0. But since I added 6 to the left-hand side, I also have to add 6 to the right-hand side. Because an equal sign is essentially a balance point. If I add weight to one side of my scale, I have to add weight to the other side of the scale, otherwise it tips. Right? So we think about this as like an old school scale that has like a balancing fulcrum on one side, right? And we have like this thing, and then it's a horrible picture, guys. Like our little trays that we put weights in, right? This is the middle, is the equal sign, right? If I want this to stay balanced, say that this has 10, I need 10 over here. Otherwise, we tip. So that's the logic we're using when we're solving equations, is that whatever I do to one side, I have to do to the other side. If I add something on one side, I add something to the other side. If I subtract, I have to subtract on both sides. If I divide, I have to divide on both sides. If I multiply, I do it on both sides. Anything you do on one side, you always do to the other side of the equal sign. Otherwise, you end up with an imbalanced scale, which means you didn't find the solution. Okay, so I add the 6 here, right? It makes the -6 on the left-hand side go away, and I only have x divided by 4 left on the left-hand side. Negative 5 plus 6 gives me a positive 1. Right? And then I'm to the next step of my process, which says I can multiply or divide to essentially get rid of whatever is going on with the variable. In this case, x is being divided by 4. So to reverse that and get rid of the division by 4, I multiply by 4 because those are opposite operations from each other. Since I do it to one side, I do it to the other side. And this right here, putting a number in parentheses and setting it next to another number means multiply. So when I do this, like parentheses 4, whatever's next to that parentheses is being multiplied by 4. Okay, so x divided by 4 times 4 leaves me with just x on the top. 1 times 4 equals 4. Okay, so then we end with x equals 4. Okay. Does that help, Nicholas? Did I get to what you were looking for? Welcome. Okay, let's look at our next one. We have 9x minus 7 equals negative 7. To be an interesting one. So we have no parentheses, we have no like terms, so that means we go to addition or subtraction. Our first step will be to add 7 to each side. Right, that means the minus 7 plus 7 goes away. Negative 7 plus 7, that's going to be a 0 on that side too. Right, so we have 9x equals 0. All right. Our next step, right, if I'm multiplying by 9 on this side, to undo the multiplication by 9, I have to divide by 9. Right, so I say divide by 9, divide by 9. The 9s go away. I have x by itself on the left-hand side. But what is 0 divided by 9? If I have 0 things and I divide it equally 9 ways, I still have 0 things, right? So we just get 0. Okay, so let's check. So I'm going to replace x with 0 in my equation. We have 9 times 0 minus 7. 9 times 0 is 0. Minus 7 equals negative 7. Yay, it worked. All right. So this was a fun one. It was fun. That's me being a math nerd. This one's a little more interesting because we end up with 0, right? Which we don't always expect our x to equal 0 in our equations, right? We expect a number to come out like a number with value. So that was a little more interesting. Next, we have 0 equals 4 plus n divided by 5. So we're going to start by getting rid of our 4, minus 4, minus 4. The 4 goes away there. 0 minus 4 is negative 4 equals n over 5. We have to get rid of the division by 5 now that it's attached to our n. So to get rid of the division, we multiply. Again, I'm using my little parentheses here to show that I'm multiplying. 5 times, and in this case, to really show that I'm doing multiplication, I have to put the negative 4 in parentheses as well, so that it doesn't look like I'm saying do 5 minus 4. Right? Two things in parentheses next to each other, multiply. So 5 times negative 4, negative 20, equals, 5s are gone, n. Right? So in this case, we have negative 20 equals n. And as usual, we will check our work. So we will say 4 plus negative 20 divided by 5. Okay, this will equal 4 plus negative 20 divided by 5, negative 4. 4 plus negative 4, 0. All right, so I multiplied by 5 on both sides because my n was being divided by 5. That's what this is doing right here, right? N divided by 5 right here. Whenever you have a variable in a fraction, right? It's showing division. So n over 5 is n divided by 5. And to reverse division, I have to multiply. And I'm going to multiply by the same number that's being divided by. Right? And we do that, right? So I'm going to kind of show this here. If I have n over 5, and I multiply by 5, that's going to be equal to 5n divided by 5, which is also equal to 5 divided by 5 times n. 5 divided by 5 is 1, n, which we just write as n. Right? And I needed n by itself, so the multiplying by 5 accomplishes that. It makes that happen. You're welcome. So when you're solving equations, you're always kind of thinking of opposites. How can I do the opposite thing that's currently being shown in the equation? If I'm adding a number, the opposite would be to subtract a number. If I'm multiplying by a number, the opposite is to divide. You know, in later processes, we could be squaring a number. Right? So the opposite of that is taking the square root. Right? There's always an opposite operation for whatever operation is going on. All right? There's an inverse. You're welcome. All right. Does anyone have any other questions about our two-step equations here? Our last ones to do, we have multi-step equations. So question 1, we have negative 20 equals negative 4x minus 6x. This is the first time we've seen something that we can call a like term. So now we're actually using step 1 of our process, right? We have two terms here that have a variable, and they have the same variable, which means I can put them together. Okay? So that means is I'm not going to add, subtract, multiply, divide, or anything yet, right? I'm going to combine the minus 4x minus 6x. And the way I do that is I just take the numbers of negative 4 and negative 6. Okay, so I have minus 4 minus 6 x. Right? So I take the numbers and then I put those in parentheses with their operations, -4, -6. Then I get the variable and I put it outside the parentheses. Now I'm going to do what's in the parentheses. Right, we get -4 -6, -10x. So I've now combined my like terms, the two terms that had a variable. So I get -20 equals -10x. Okay. I'm going to rewrite this over here. I have -20 equals -10x. Now, I can move on to my step 2, which would be add or subtract. I don't have any numbers to add or subtract on the right-hand side that's along with the variable term. So I get to skip to multiply or divide. In this case, I need to undo or do the opposite operation of multiplying by -10, which means I need to divide by -10. If I divide that side by -10, I divide this side by -10. Right, my -10 is gone. I'm left with only x. -20 divided by -10 is 2. So we end up with 2 equals x. Now, we want to check our work. Right, unfortunately, these problems ended up closer together than I wanted them. So, I'm going to check over here. And I'm going to put 2 in place of x for this equation. So I have -4 times 2 minus 6 times 2. Right, -4 times 2 is -8. Minus 6 times 2, 12. -8 minus 12 is -20, and that's what I wanted. Okay. What questions do you guys have on this one? This is the first time we've seen a combining of like terms. Okay. All right. So now, question number 2. We again have like terms. However, this time, instead of having like terms that both have a variable, we have like terms because we have regular numbers on the same side of the equal sign. So we have to combine those first. So we have a 1 and a +5. Okay, so we'll have 6 equals. So I'm going to take this -2n and just drop it in down here. Nothing is happening to that yet. I'm taking care of my like terms first. And then we have, this would be a +1 and a +5, so we can say +1 +5. Six equals -2n plus 6. All right, we've combined our like terms. Now we can do the addition or subtraction step. In this case, we'll do a -6 on both sides. All right, our +6 - 6 is 0. +6 - 6 will get 0 over here. Move this on up here. We have 0 equals -2n. All right. Divide by -2, divide by -2. The multiplication is canceled by the division. 0 divided by -2 is still 0, equals n. All right, and then we'll check. And we will put in 0 for n in our original. We have 1 minus 2 times 0 plus 5 is 1 minus 0, because anything times 0 is just 0, plus 5. And then it's 1 plus 5, which equals 6, and that's what we wanted. All right. What questions do you guys have? What can I clarify about the first two multi-step equations? Yeah. All right. For number 1 or number 2, Eileen, which one do you want me to clarify? Number 2. All right. So whenever I'm checking my work and I'm checking my solution, I only write down the part that has the variable. So in this case, I'm taking the right-hand side of the equation. And I want to make sure that when I replace n with my solution, 0, that my result is 6. So I leave the equal 6 part off, so to say, and I write down 1 minus 2n, but in this case, n was 0. Right? So the 0 is here where n would have been in the original equation, plus 5. Right? So I do the multiplication first, because the order of operations, I have to do multiplication before I do addition or subtraction. Okay, so 2 times 0 gives me 0. 1 minus 0 plus 5 equals 6. And the 6 is what we needed this to equal to when I replace n with 0. Okay. Does that clarify for you, or did I miss something? Good. All right. Thank you for asking for clarification. All right. So here, number 3 gets a little more interesting. Right. I now have a variable on 2 sides of the equation, on both sides. All right. I have a variable with 8 over here, and I have 7x over here. Now, I need these on the same side. I need x on my variable on one side of the equal sign, and numbers on the other side. I can't have the variable on both sides, or else I won't be solving it. I've got to move stuff around. Right. So, the variables, you just put your answer into the variable. Yes, exactly. So Eileen was asking in the chat, she says, so when you check the ones with variables, you just put your answer into the variable in the equation. Yes, that's how we check. We use what's called substitution. I substitute the variable with the value I just found as a solution. Right? And if I did everything well, I should get the expected result. In question number 2, it was 6. All right, so this one's going to be a little more interesting as far as like how we check it and how we solve it. Because like I said, we have a variable on each side of the equal sign. So I'm going to choose which side I want the variable on and which side I want numbers on. Okay? So I'm going to have variables on the left-hand side and numbers on the right-hand side. So I got to move stuff around. The first thing I'm going to do is subtract 7x from both sides. And this is because I need the variable gone from the right-hand side and existing on the left-hand side. So plus 7x minus 7x is 0, right? It behaves just like a number. If I have 7 times something and I subtract 7 times something, that's gone. It goes away. So I've gotten rid of the variable on the right-hand side. But to keep everything balanced, I have to do that same thing to the left. So we have 8x minus 7x minus 2 equals negative 9. I'm now going to get the numbers, right, all on the right-hand side. So I'm going to take this negative 2, or the minus 2, I'm going to add 2 to the left-hand side, add 2 to the right-hand side. The number that was on the left-hand side is now canceled. And I'm just left with 8x minus 7x equals negative 9 plus 2, negative 7. Now I need to combine like terms. Right? On the left-hand side, I have 2 variable terms, and they both have x. They have the same exact variable, so I can combine them. And again, when I do that, I look at the number in front of the variable. And I have to take the sign with it. So what I get is going to be 8 minus 7 x will equal negative 7. Right? 8 minus 7 is 1. So we end up with 1x equals negative 7. Right? If it's just 1x, I don't need to write the 1. 1 times anything is just that thing again. 1 times x is just x. So we end with x equals negative 7. So now we have to check. Right? This one involved a lot more steps, a lot more rearranging of our equation. So when I check each side of the equal sign individually. And if I get the same number from both sides of the equal sign, then I've found the solution. I've solved the equation correctly. So I'm going to look at 8x minus 2 first and replace x with negative 7. So I'm going to say 8 times negative 7 minus 2. Right? 8 times negative 7 will be negative 56 minus 2, negative 58. All right. So this was the left-hand side, which I did first. Now I need to check the right-hand side. So I go negative 9 plus 7 times negative 7. Wait. Sorry. It's horribly written. There. All right. So again, I do my multiplication first. So I'll have negative 9 plus 7 times negative 7 is negative 49. Negative 9 plus negative 49, negative 58. Negative 58 equals negative 58, right? I got the same number from each side of the equation, which means I solved it correctly. Right, so how do you know? All right. So it's a very good question, I think. So Eileen's asking, like, how did I know to subtract negative 7x when I started this equation? So I have two options. I chose to subtract 7x and move essentially my variable to the left-hand side of the equation. I could have subtracted 8x, which would have resulted in my variable ending up on the right-hand side of the equation. It doesn't matter which one you choose, you should get the same result. Yeah, so Jocelyn, you're asking, yeah, would it be the same if it was 8x? So yeah, we could do the same problem, right? And subtract the 8x instead, and we'll get the same result. Let's show that for clarification. So look, if we start over, right, we go 8x minus 2 equals negative 9 plus 7x. And I'm saying, okay, let's subtract 8x from both sides. Okay, so we have 8x minus 8x, that's gone. Right, and we get negative 2 equals negative 9 plus 7x minus 8x. Right, we'll do the same thing as we did before. We have negative 2 equals negative 9 plus 7 minus 8x, right? I took the coefficient from each like term, the 7 and the minus 8, and it goes into the parentheses here with the variable on the outside. Okay, negative 2 equals negative 9. 7 minus 8 is negative 1. Right, so we have plus negative 1x, essentially. Right, we get minus 2 equals negative 9 minus x. Right. Negative 2 equal, or sorry, got ahead of myself. Now, we're going to add 9 to each side. Negative 2 plus 9 equals 7. Right. Negative 9 plus 9 is gone, equals negative x. Right. Negative x is not what I want. I need positive x. I just need x equals. I can't have negative x equals. So to undo the negative, I multiply by negative 1. Because a negative times a negative is a positive. So I have negative x times negative 1. That results in canceling of the negative sign, essentially. Right? Negative 1 times 7, negative 7 equals x. Right? So, if you get down to why did I choose to do minus 7 instead of minus 7x instead of minus 8x, it's because it resulted in less steps. I know that I want a positive variable at the end. I want a positive x. I don't want negative x. It makes me have to do extra work. So because 7 was smaller than 8, I knew I would end up with a positive x on the left-hand side by doing it that way, which results in a little bit less work. So that's the why I chose to do it that way. Both ways are correct. One just involves a few more steps. Okay. All right. Hopefully that answered your question. So we have one more here. It's all buried, so I'm going to rewrite it down here. You're welcome, Jocelyn. So number 4 here, put over here. We have a plus 5 equals negative 5a plus 5. All right. So again, I have variable on each side. So I need to move the variable term to one side and the numbers to the other side. Now again, strategically, I want a positive a, and I want negative. So I know that if I add 5a to each side, I'll have a positive value for a at the end. I won't have extra steps. So I'm going to do that. I'm going to say plus 5a plus 5a minus 5a plus 5a cancels out. And then we have a plus 5a. We can also think of this as 1a plus 5a. If I have 1a and I add 5 more a's, 6a. It's a weird looking a. Okay, plus 5 equals 5. We have to move our number now. We do a minus 5 on each side. Minus 5. 6a equals 0. Divide by 6. We get a equals 0. And now we're going to check number 4. So I'm going to replace a with 0. We'll do the left-hand side first. So we have 0 plus 5 equals 5. And we'll do the right-hand side. We have negative 5 times 0 plus 5. Negative 5 times 0 is 0 plus 5 equals 5. 5 equals 5. We got the same number on both sides of the equal sign. Yay, everything worked. All right. Whew. That's a lot of math. Scroll up a bit. Yes. Is that enough, or you need a little bit more? There's good. Okay. It's very busy. One thing I will suggest is when you solve equations, try to be organized, right? This is how it looks when I solve equations. If you need to like draw like columns or something to keep your like operations more organized, do that. But you know, it's kind of up to you on the organization side. I do the kind of like inline process. If you notice, like my you're welcome. My equal signs, right, tend to stay lined up. That's just how I learned how to do it. I keep the equal sign just kind of like running through the middle. You know, that's just me.